Hello, hi everyone. Welcome back to my YouTube channel, and today we are going to solve yet another classic problem of reversing a singly linked list, but in a very interesting way that you'll never forget. I know it's a tall claim, but trust me, once you understand this algorithm using the technique that I'll demonstrate today, you'll never have to look this up again. And I call this method as the SRK method of reversing a singly linked list. Yes, you heard it right. The Shahrukh method of reversing a singly linked list. That will clear up all your doubts for good. So let's get started. Okay, let's quickly try to understand this algorithm and why we are calling it as SRK or rather SRQ. So here we'll be using three pointers S, R and Q to reverse this entire linked list, and the variable K will also be used in the later variations which we'll see in the coming slides. So at any point of time, if we'll observe, we'll have three pointers. The first pointer is S, which is following R, which is following Q. So the purpose of Q is to simply iterate through the entire linked list starting from the head node until it reaches null. And if I could represent this in the form of a code snippet, then you can see on the top left of the screen that there would be a while loop which is running until Q has not reached null, and every time we have to do Q equal to Q next. So this means Q will be starting from head, and then it will move to 2, and then it will move to 3, then to 4, which is the last node, and finally it reaches null, and then we'll break out of the while loop. Now that we have understood the purpose of Q, let's quickly understand the purpose of S and R. These two are used to reverse the pointers of the two adjacent nodes. And how? Let's quickly see. So R next is equal to S would be the code snippet, and just for the sake of simplicity I have shown only two pointers here. Obviously Q would still be here, which is pointing to 4. But I have only shown S and R. So what exactly happens is R, which is sitting between S and Q and which is pointing to Q, will now be removed from there and it will point back to S, which is what I have written on the top left, right, which is R next equal to S. Now this will reverse the pointer. Now I hope you guys have got it so far. We have understood that there will be three pointers S, R and Q in the same order, just like SRK. So that's the way you can remember. And what is the purpose of Q? To iterate through the entire linked list, and the purpose of S and R would be to reverse the pointers. Now at the very start there will be three pointers, as we have already understood S, R and Q. S will be following R and R will be following Q. In the very start we'll also do some initialization, so Q will be pointing to head, that's where we start the iteration process. And since R is falling behind Q, so R will be pointing to null. At this point of time, you can also initialize S equal to null, but that would be redundant, and hence I haven't shown that. Now what will happen? We have to simply iterate through this entire linked list using the pointer Q, as I have shown in the while loop. Now before moving Q to the next node, we have to do a few things. Let's quickly understand what are those things. As we have already understood that there would be three pointers S, R and Q in the same order. So that's why before we move Q to the next node, S has to take place of R and R has to take place of S. It means S equal to R and R equal to Q. So this is exactly what we have done. S has now taken place of R, which is null, and R has now taken place of Q, which is pointing to the head node denoted by element 1. Now once we have done this, only then we'll move the Q pointer to the next node like this. Once we have this configuration of SRQ, we will simply reverse the pointers using R. How? R next equal to S. It means R, which is sitting between S and Q, and R, which is pointing to Q, will now point back to S like this. Now let's move on using the same logic. Now S will take possession of R and R will take possession of Q. Q will move forward. Then we'll reverse the pointer R next equal to S. Now again S will take possession of R will take possession of Q, and then Q will move forward. Then again we'll reverse the link like R next equal to S. Again R will take possession of Q and S will take possession of R. Now again what will happen? Q will move forward. So again R next equal to S, and we will point back. Now at this point of time you are seeing that Q has already reached null. It means we have already broken out of the while loop, and the entire linked list is also reversed. The first node, which was initial head, is now pointing to null, which is also correct. The only last thing that we have to do is we have to reverse the head pointer to this modified linked list, which is reversed. So as we can very well see at this point, which is the pointer that is sitting on the last node of this linked list, which is going to be the new head pointer. That value is r. Hence, in the code, what we'll do, we'll simply return r, because this is going to be the head of the new modified linked list. Now, many people would argue, what if we are presenting this solution in front of an interviewer? Would it be okay to use these kind of variable names, SR and Q? So trust me, as a bar raiser at Amazon, I have taken 900 plus interviews. And if you are able to explain this algorithm well and write this solution even using SRQ, the interviewer would be more than happy. But if at all required, you can always tell them that, hey, we can always rename these variables like these. So now Q can be thought of as a current pointer because we are always iterating through the linked list, right? Starting from the head node until the null has reached. Since R is always falling behind Q, so R could be thought of as a previous pointer or a pref pointer. And since S is following R, it could be thought of as prev of prev or previous of previous. So this is just one convention. You can always tell this to the interviewer and they will give you some bonus points. So don't worry about SRQ as far as your algorithm is right and you are able to explain your algorithm to the interviewer. Now let's try to solve another hard problem using the same SRK method that we have learned just before, and this is where the value k comes into picture. So in this problem, we have to reverse a singly linked list in batches of k or in groups of k, and there is a single linked list which is given on the screen. As we can see, 1, 2, 3, 4, 5 and 5 is pointing to null, and there is a value k which is given 3. It means we have to reverse a linked list in groups of 3. So the output would be something like this. The first 3 blocks will be reversed, which is 1, 2, 3 will become 3, 2, 1. And the remaining 3 or less than 3 blocks, it means whatever are the leftover nodes, that should also be reversed. So this is the question. So the last 2 elements, which is 4 and 5, will also be reversed and it will become 5 and 4. Now in order to solve this question, we'll take use of the previous code snippet that we have learned just before. And let's try to compare and contrast and see what kind of additional things that we can add onto this code snippet to solve this problem. So the very first change that we can see is our function prototype will change, and now it will have 2 params, will pass the head pointer as well as pass the value of k. The second change would be we have to keep a count, let's call it as C, a counter, which will keep on counting the number of nodes that has been processed. The while loop will also change in a manner that we want to break out of this while loop if Q has already reached to null or C has already reached to the value of k. It means we have already processed the k nodes. Then inside the while loop, we have to increment this count, and this could be added anywhere within the while loop. At the end, before returning the head pointer, we have to write one more line. As you can see, head next equal to reverse of qk. Now this is a complex line that I've already added. Let's try to understand what this is. Now look at the new diagram very carefully. This is the time when we'll break out of the while loop for the very first time. It means when we have processed the first k nodes or the first 3 nodes, right? Because the value of k is equal to 3. So essentially, as you can already understand, since we are already in the while loop for the first 3 nodes, so these pointers are already reversed like this. Now if you are also watching and understanding carefully, you can also find out what could be the possible position of SR and Q at this point of time. It would be like this. Q will be pointing to the 4th node, right? And S and R would be pointing to the first 3 process nodes like this. So now let's try to solve this second part of the linked list as a subproblem, which I've already highlighted here. So a very simple logic could be, though we haven't understood anything about recursion, but how we can solve it is we can use the same reverse function and we just have to pass the new params. So in this case, the first param, which used to be the head, will be Q in this case, because Q is the head pointer of this particular sublist, correct? K will remain same. Also, we have understood that this reverse function will always return me the head of the modified linked list. the modified reversed linked list. So in this case, when this recursion will give me the value, the new head would be pointing to 5, correct? So now we have solved both these questions, like the first subproblem on the left and the second subproblem on the right. One thing that is missing is we will always return R as the new head of the entire linked list, but we have to join these two results. So how that join can happen? Just take quick 30 seconds and you will know what you need to do. So the node which is shown by head, which is 1, that should be pointed to the result of this reverse function. It means head next is equal to reverse of qk. If we do this, then it means we have completed our chain, we have completed both the results, and we have fixed the pointers as well. So that is why this statement is very crucial, and just spend another 10 seconds and I hope this might be very clearer to you. Okay, now we are going to dissect this code and understand it until we really understand it. And जैसे मैंने बोला था कि पूरा कोड आज समझ के जाएंगे. नहीं यार, हिंदी नहीं बोलनी है. So first things first, the very first thing is the function prototype or the function method. So as you can see, the name of the function is reverse, and we have to pass the head pointer as param, and we have to return the head pointer of the modified reversed linked list. So this is my function prototype. The next is the initialization step. So we will initialize q with the head pointer and r with null. Then what will be the next step? We'll do a while loop, which is only used for iterating through the entire linked list using q, and until q reaches null. So it means until q is not equal to null. Now many people might have been thinking why I have always been telling you while q is not equal to null, but I'm not really writing it, right? This part. The reason is, no matter whether you write like this, it is totally redundant, which is kind of useless. So possibly what I can do is I can make another video where I can show you how to optimize these code snippets which are kind of redundant and we still keep on writing it in our day-to-day solving of data structure problems. Now moving forward, what we need to do is S has to take the place of R and R has to take the place of Q before we move the Q pointer, right? So the next step is Q is moved forward to the next node. Now let's also double tap these three statements, which is highlighted as yellow. Now do you see any kind of resemblance in this, the one that is highlighted in yellow? It seems similar to the one where we are swapping two values A and B using a third variable C, right? C equal to A equal to B equal to C. So in the very same fashion, this is more like a song that goes into my head. S equal to R equal to Q equal to Q next. So what I'm really doing here is I'm just giving you all the possible tools of not just understanding this algorithm, but to remember this code, right? Like not mug it up, but to still have a certain intuition in your head, have a certain mapping in your head that how can I write this code? Because often what I've seen is, at least when I used to interview a lot of candidates, like people take almost 5 minutes, 10 minutes or even 15 minutes and they are still puzzled just to reverse a linked list. So forget about any hard problems which are based on top of this particular template. So do remember all these points. Now let's quickly move on to the next step. The next step is just reversing the pointer. This is where we swap pointers or we reverse pointers. R, which is pointing to Q, will now point back to S. And just to juggle up your memory once again, this is how it looks. So R is sitting well between S and Q and R is pointing to Q. So now instead of R which is pointing to Q, R will point back to S. Now the final nail to the coffin or the final step is we simply have to return R. So R is the new head pointer to this modified reversed linked list. Now let's look at another variation of this implementation. What if instead of returning the head pointer to the modified linked list, if we have to do it using a void function, it means we don't have to return anything. So there is a small change in passing the parameter. So instead of passing just the pointer to the head, we are passing the reference to the head pointer. Anybody who has just a small amount of idea about C++ pointers, they would be able to get it. And within the body, there will not be any changes except the last statement, since it is void and we cannot return anything. So what we'll do is we'll simply assign R to head, and that's it. We are done. Now let's look at another hard complexity problem, which we can solve using the same template. So let's say my input is my name is Pratul, and the output that we demand is Pratul is name my. However, there is a catch. The first constraint is this input is represented in the form of a singly linked list. So first of all, this is not a string. And how it is represented? Every character is wrapped in the form of a node. So it means M is pointing to Y is pointing to space is pointing to N, so on and so forth, until the last node, which is L, and L will be pointing to null. What is the second constraint? We need an in-place solution. It means we cannot take any extra auxiliary space, meaning we cannot store these characters into some arrays, or we can take a stack, put these characters there, or we can take a queue. So we cannot do that. We have to find out an in-place solution, meaning your auxiliary space complexity should be O of 1. Now let's quickly look at the solution. So it can be done in 2 steps. Step 1 is we have to reverse the entire linked list. So I'm just telling about the algorithm, how we can do it. So we already know how to reverse a linked list. So this is how it will look. Just for simplicity, I'm not showing the pointers here, but the input statement will turn like this when we reverse the entire linked list. Step 2 will be, now you have to reverse individual words separated by these spaces. So this will turn back into Pratul is name my, which is the desired output. Now instead of doing in this fashion, we can also swap these steps. So even if we reverse individual words first and then reverse the entire linked list later on, you will still get the same output. So that is a choice that you can exercise. So now it's time to do some live coding and reverse a linked list. So we have node S, R and Q. We'll take 3 pointers as I've already mentioned. Then Q will be pointed to head, R will be equal to null. Then we'll start a while loop. Then again, there is a song in my head, S equal to R equal to Q, and Q equal to Q next. Then we'll reverse the pointer, R next equal to S. And then finally what we'll do, we'll simply return R. And we'll submit. Let's compile first. Done. Let's submit this. Yep. It's running. Yep. Okay. So it's done. So as you can see, it took me less than 15 seconds or probably 20 seconds, not even 30 seconds to implement this solution, right? So it is that effective if you understand this, and you will remember it for a lifetime. So now live coding 2.0. This is the variation what we have done, reverse a linked list in batches of k. So what I'm doing here is, let me first copy the same code that I've written just before, and let's do some quick modifications. We already know what those modifications are. We'll say c is equal to 0, right? Then what? C++ here, you can put C++ anywhere, and while q and c is less than k. This is the second modification. Here node have to be small case, right? Just because this is the way that they have implemented it. And finally here, if head, right? This is just for the null case thing. What we have to do is head next is equal to reverse. The function name is reverse it. So I will put q and k, and let's quickly submit. Okay, so it's running, and yeah, it also got submitted. How much time did we take? Not more than 1 minute if you have to write this entire thing. Now let's move on to this third problem. This is similar to that reverse node in batches of k. However, there is a catch, and it's a Leetcode hard problem. So initially what we were doing is we were reversing the batches in k, and whatever are the leftover nodes, right? You can see whatever are the left out nodes, we are also reversing that. In this question, the variation says that whatever are the left out nodes in the very last, you don't have to reverse it. So for example, this is the linked list and k equal to 2. So we will get the output 2, 1, 4, 3, but the last node, which is the left out node, will remain as it is. Or probably this can be understood much better here if k is equal to 3. So 1, 2, 3 will become 3, 2, 1, but 4 and 5 will not become 5 and 4. It will remain as 4 and 5. So obviously I will not implement it again, but you can see, right, I'm using the same template and I'm just doing some kind of tweaking here, and I'm able to complete this question. I probably took 3 to 4 minutes or maybe 5 minutes to implement this question, and it's a Leetcode hard, right? So this is the power of SRK method. Okay, now looking at another hard complexity problem which I have already explained, but we haven't done the coding for this, right? Where I have given my name is Pratul and the answer should be Pratul is name my. So this is exactly the same question as I can see on Geeks for Geeks, and this is the implementation that they have done. You can see, right? Such a lengthy implementation, and it's not about the length actually, it's more about understanding this algorithm. If I really have to understand and read this algorithm, probably it will take ages, right? Like you really have to understand what is going on here, correct? So I'm not saying it's a nasty code that somebody has written here, but let's try to solve it using our own template. Now what I'm doing here is I have copy pasted the entire code snippet from Geeks for Geeks, but we will not use their lengthier reverse function to solve this problem. It is quite horrific and quite terrible to understand. So we are smart and we'll use our SRK method, right? So you remember the first step, we have to reverse the entire linked list. So this is that function, and I'm using the void variation of it, which you are quite aware of. The second step that we need to understand is this one. This is going to reverse individual words separated by spaces. So this is more like reversing the linked list in batches of k, except there is no k. So what we have to do is a slight modification. We will break out of this while loop if q has already reached null or we have encountered a space. So as soon as we break out, we have to do two things. One, let's say q could be possibly null or q could be space. So I'm just pointing the head next to q. And second, we have to reverse the individual words. We'll call the regression function like this. So q next, which is the start of the second word, is equal to reverse of q next. And what I've done here is why I have used if head and if q. Quite simple, just to ensure that I don't get a null pointer exception, especially in these cases. What if head is null, then this will break, right? This will also break. So this is just a small condition that I've mentioned here. Now let's quickly solve this problem. So I've used these two functions, reverse and then reverse words. This should give me the output. But just to give you guys a view, let me comment this out first and let me compile this function. So first you can see, right? The entire linked list is reversed on this right side. Now let me uncomment this. So now I will reverse individual words also. Now I'll compile and you see we already got the answer. Pratul is name my. Using the same technique that we have understood, the SRK method, these two variations. Okay, bye bye, take care.